Hello, I am Hatice Birtane from Marmara University, Department of Chemistry. Today I want to talk about the production of flame retardant paper with DOPO. In this study, in order to prepare a flame retardant paper coating, DOPO derivative was synthesized with 3-aminophenyl sulfone and benzaldehyde reaction. And the chemical structure of DOPO is eliminated by FTIR, then paper was coated with a flame retardant coating formulation with DOPO. The paper's properties were investigated. Surface energy of coated papers and contact angles were determined with goniometry. Printability parameters such as color, gloss, surface tension were examined. The results showed that the DOPO-added paper coating improved the paper flame retardants. What are flame retardants? Flame retardants are chemicals that are added or applied to materials in order to slow or prevent the start or growth of fire. Flame retardant materials represented to provide fire resistance, to prevent or suppress the combustion process, or to allow slow combustion in materials were rare and required special handling methods. If we want to classify the flame retardant materials, we can divide them into 4 groups. These: nitrogen-containing flame retardants, halogen-containing flame retardants, inorganic compounds-based flame retardants, phosphorus-based flame retardants. Nitrogen-containing flame retardants essentially provide inert gas released to the environment during combustion by reducing the oxygen concentration in gas phase and slowing down the combustion process. Nitrogen-containing natural polymers such as wool, silk, leather provide a fire resistance. Thus, some nitrogen-containing organic compounds are used in polymers as additives to show fire-resistant properties. Melamine is commonly used for flexible polyurethane foams in furniture and upholstery in transport vehicles. In addition, melamine cyanide is used in polyamide 6 and polyamide 6.6. Moreover, zinc or aluminum containing melamine polyphosphates are used in cables. Halogen containing flame retardants. Among these flame retardants, brominated flame retardants are well-known ones. They are generally used in electrical equipment. Fire can be occurred in short circuits and electrical malfunctions. Also, brominated flame retardants are used in insulation of wires and cables. What is more, they are also applied in fabrics such as curtains, seating, and furniture in transportation and public buildings. Halogen-containing flame retardants may work in vapor phase or in the condensate phase. Inorganic compounds-based flame retardants. Aluminum hydroxide is mostly one of used flame retardants in this group. It is cheap, but the quantity of aluminum hydroxide must be more than 60% in polymer, because its mechanism is based on the release of water by cooling and releasing the flame. Magnesium hydroxide is applied in polymers. Aluminum hydroxide and magnesium hydroxide are used in the thermoplastics like cable, PVC or polyolefins. Using in cable, aluminum hydroxide and magnesium hydroxide are applied with natural products to develop their valency with the polymer. When the aluminum hydroxide is heated, an endothermic reaction is occurred and it separates to form water and aluminum. When the water is formed, it transfers to the vapor phase and causes the reduction of heat transfers during combustion. Mineral containing flame retardants are generally applied in thermostats for electric equipment, vehicles, and panels. Borate-based flame retardants are mostly used in wool and cotton products. Borax and boric acid are commonly used together. One of the reasons why boron-containing additives are used as flame retardants is that they undergo endothermic dehydration and water is released after this action. Among the boron-containing compounds, zinc borates are the most commonly used. Phosphorus-based flame retardants, both organic and inorganic phosphorus compounds, provide flame retardant properties for many polymers. These compounds are actively used in the industry as a reactant and additive. In addition, certain flame retardants based on specific phosphors, such as methylphosphonate, may have negative effects on burning, forming phosphorus and phosphate radicals in the gas layer. Phosphorus-containing flame retardants are mostly used in the plastic, textiles, thermostats, coatings, and other applications. They have a wide application field and a good fire safety performance. Phosphorus-containing flame retardants are widely used in the industry. Therefore, non-halogenated phosphorus-containing flame retardants are mostly focused due to their less toxic properties on the materials. A coating is a covering that is applied to the surface of an object, usually referred to as the substrate. The purpose of applying the coating may be decorative, functional, or both. The coating itself may be an overcoating, completely covering the substrate, or it may only cover part of the substrate. Why is the flame retardant coating important? Flame retardant coating and films prevent or delay the ignition of valuable documents, check, money, valuable book, or printed paper used in a home environment, thus providing features such as providing extinguishing time or preventing the spread of fire. When we come to the experimental section, in our study I synthesized DOPO containing compounds. 64 millimole DOPO, 32 millimole 3-aminophenylsulfone, and 64 millimole benzaldehyde were dissolved in tetrahydrofuran. The mixture was stirred at 30 centigrade for 24 hours under a nitrogen atmosphere. The mixture was filtered and then white product was obtained. Subsequently, the crude product was added to the tetrahydrofuran solution and stirred. The solid was filtered and then precipitate was washed repeatedly with tetrahydrofuran. The synthesis scheme of the DOPO derivative compound is shown in this figure. If we answer the question of how we prepared the coatings, as can be seen in the formulation table, the base formulation is composed of 3-methyl propane triacrylate, 2-hydroxyethyl methacrylate, and polyethylene glycol diacrylate. The synthesized DOPO derivative in 1 3 and 5% proportions was added into the formulation, and paper was coated. And then the coated papers were cured under ultraviolet irradiation. DOPO containing paper coatings were characterized via FTIR spectroscopy and thermogrammetric analysis. The FTIR spectra of paper F0, F1, F3 and F5 formulations are given in this figure. The band at 1637 and 1581 minus 1/centimeters in FTIR spectra of F1, F3 and F5 are due to phosphor-phenyl striding vibrations. The peak at 1155 minus 1/centimeters is attributed to the phosphorus double bond oxygen stretching. Sulfur double bond oxygen peak is shown at 1405 wave numbers. The thermal stability of uncoated paper and paper coatings were evaluated with thermogrammetric analysis under nitrogen atmosphere. Thermogrammetric analysis thermograms of paper F1, F3 and F5 formulations are shown in this figure. Under nitrogen atmosphere, with the increased DOPO containing compound percentage, T5 and Tmax were increased. The maximum weight loss temperatures and the residual masses increased with increasing amount of DOPO containing compound. From this result, it is concluded that the addition of DOPO containing compound improved the thermal stability of coated papers. In previous reports, it was also shown that the thermal stability improves when DOPO containing compound is incorporated into paper coatings. The contact angle values and surface energy values of all containings are given in this table. The water contact angle of paper without any coating was measured as 82 degrees. When 3% DOPO containing was added to coating formulation named F3, the contact angle decreased to 34.9. On the other hand, the contact angle value of the DOPO containing papers decreased. This is due to the presence of the hydrophilic group in DOPO containing compounds. Color and gloss properties of coatings. The color values of the coated and uncoated papers are given in this table. Color differences were calculated by delta E of substrates F0, F1, F3 and F5. How it differs from base paper. When the table is examined, the most changing parameters of the color is R. This shows that the lightness has become darker, not the color. In other words, the color of the paper has not changed much. Only the lightness of the color has changed. When the color differences are examined, The color difference caused by the change in the alveoli is too high. However, the difference is not much in the visual inspection. When the gloss value was examined, it was determined that all coatings were very glossy compared to the base paper. Because the polymeric coating formulation fills the voids on the paper surface and reduces the diffuse reflection. Thus, the smooth reflection and gloss increased. However, with the addition of DOPO to the formulation, the roughness increased a little, so the gloss decreased. However, it still has a glossy surface than base paper. The gloss decreases as the amount of DOPO increases. Finally, if we examine the flame retardancy properties, the flame retardancy properties of DOPO-containing paper coatings were examined with Loewy measurements. Loewy values of coated and uncoated papers are given in figure. As can be seen from figure, when the Loewy results are examined, it is seen that all the coatings on the base paper increase the Loewy and make it difficult for the paper to ignite. However, this increase was effectively increased with the addition of DOPO to the coating formulation. In other words, it is more difficult to ignite in coating with DOPO added. In addition, as the amount of DOPO increases, the Loewy value increases slightly. Compared to the base paper, the F5 coating that gives the best Loewy result, the Loewy value increases by 30.2%. If we summarize the results of our study, according to FTIR results, DOPO-containing paper coatings were prepared successfully, and DOPO-coating paper has been given flame retardancy property. Thermogravimetric analysis thermograms was also shown that the thermal stability improves when DOPO-containing compound is incorporated into the paper coatings. When the results were examined, it was determined that DOPO increased the Loewy value and made it difficult to ignite. According to the obtained Loewy results, it is concluded that there will be more time to save printed products in a possible file. Thank you very much for listening.